liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Throughout our history as a sentient species, the moon has always inspired a plethora of emotions. Whether it be the fear of the unknown or the joy of discovery, this relatively small greyish orb orbiting around our world has always offered something to be desired. And it still does today. The moon offers modern society several benefits that outweigh the risks of a return trip, including abundant fuel for future fusion reactors, an unparalleled center for scientific research, and, at the more radical end, the ultimate shelter, which could shield a small portion of humanity from any cataclysmic occurrence on Earth.
It's not every night that we get a full moon like this. That huge luminous disc, all the way up there. A future power source. A power source which has the unmatched ability to generate power with little to no waste. That power source is Helium-3 is a crucial component in creating fusion. Today's fusion reactors are mainly experimental, but they have already broken several milestones. This includes the NIF's experimental laser array, only half an hour away from tracing.
Fusion is not easy. Temperature needs to be in excess of 10 million degrees Fahrenheit. That's higher than the temperature of the sun. There are, however, several ways to accomplish this. One of the current favorites, at least in the US, is with lasers. Now, most of us probably think of lasers as something that look like this.
I'm a firing the laser!
It's true that no self-respecting supervillain would be caught with that one. However, lasers can also be used for peaceful purposes such as CD players, burners, and awesome chess. The NIF laser mentioned earlier uses 198 lasers to ignite a single pellet composed of a combination of deuterium and helium-3 to around 27 million degrees. By following Einstein's world-famous law E equals mc squared, the reactor can convert matter into pure energy. And this energy output is enormous. The material can yield almost 9 times 10 to the 16th units of power. Yes, that's with 16 zeros. For the South Pole Research Station, our Arecibo radio telescope in Puerto Rico, and the Mauna Kea Observatory in Hawaii all have in common. They're all located in some of the most remote locations on the planet. Research about our universe often requires the absence of human activity. Radio waves, pollution, and other factors can mess up almost any telescope. And what is more remote than the moon? There's always Pluto, but good luck getting it. Imagine this scenario. A huge asteroid, unseen by astronomers until it was too late, plunges toward Earth. It impacts with a force equivalent to that of thousands of nuclear weapons, creating a crater 15 miles wide. This sets off a worldwide chain of chaos that cannot be stopped. As crops fail, livestock die, and governments fail, society breaks down into sheer confusion. Humanity falls apart, and life on Earth, or as we know it, is dangerously close, fading away. Now imagine a small moon base that contains DNA samples of every living species crucial to the continuation of life on Earth. Also inhabiting the colony are a select group of people who, if needed be, could reboot society, albeit at a slow pace. This fail-safe doomsday shelter, although a radical idea in the minds of many, could be a long-term benefit of a return trip to the moon. Although, right now, a moon base is out of our grasp, a return trip is a step in the right direction. Better to be safe than sorry. A mining station, observatory, and a doomsday bunker appear to be straight out of science fiction, and in many ways they are. But like cell phones, tablets, and computers, it's possible to rip these lunar engineering feats from the page
We have the funding, and we've done it all before. All we need is a lot of government help and a little matchmaking.